The dream machine. .com, HL7, IAT, and Snap. We're building the future, never looking back.
Welcome to the Imaging Informatics Unplugged podcast. This is where we try to simplify the complex in the world of imaging informatics. Today, this episode is a little different. MIIT 2025, it was an amazing success. This was just a couple weeks ago. So we're hot off the heels of this amazing event where some of the brightest minds in imaging informatics descended upon Hamilton, Ontario, and talked about a range of topics. I was honored to be part of this. And instead of a typical recap, what we did is we took all of the presentations, we threw them into Notebook LM, which is a generative AI tool from Google that helps create podcasts like what you're about to listen to. And we wanted to see what kind of summary it could build. And the result is surprisingly solid. There are a few key moments that were missed. Like, for example, it didn't mention David Koff, the founder of the event, but it does give a great sense of the major themes, ideas, and takeaways from MIIT. Now, if you're watching the video, you can thank or maybe blame a tool I used, Rev AI. This is a generative AI tool that takes audio and tries to form it into video. Full disclosure, some of these videos, they look like what AI would be dreaming if it had cheese before going to bed. They're a little out there. So if you start feeling like you're having a radiology-themed fever dream, you're not alone. Let me know. I'd love to hear your feedback if you'd prefer a static page or these uncanny valley type visuals. And if you didn't make it to MIIT, make sure to keep your eye out for next year. And we are excited. This community keeps growing, and it's one of the most energizing events in the space. So with all that said, be sure to like and subscribe this, and we'll jump into the interview.
We're jumping straight in today, looking at medical imaging through the lens of the recent MIIT 2025 conference.
That's right. MIIT, Medical Imaging Informatics, and Teleradiology. Lots of ground covered there.
Definitely. We've gone through a whole stack of presentations to pull out the really key stuff, how AI is changing things, new tech standards.
Yeah. And cybersecurity, workflows, even getting care to really remote places. It's all part of the picture.
So our mission for this deep dive is pretty clear. Cut through the noise, grab the essential insights from MIIT 2025.
Give you a solid handle on the advancements, the hurdles, the cool stuff happening without you having to sit through hours of talks.
Exactly. Your fast track to being up to speed.
Sounds good. So where should we start? AI seems like the obvious place. It was everywhere at the conference.
Yeah, let's do AI. It's funny. I remember back in, 2016, Jeffrey Hinton?
Oh, yeah. The radiologists are obsolete in 5 years prediction. A bit bold, perhaps.
Just a bit. It's 2025 now. So what's the actual story? Did he get it right?
Well, no, not in the way he meant. Complete replacement, definitely not. What we're seeing, and what Dr. Kotler really emphasized in your keynote, is augmentation.
Augmentation. So helping radiologists, not replacing them.
Precisely. AI is fantastic at specific, often narrow tasks, finding certain things on a scan, maybe measuring something.
But it doesn't have that, overall clinical judgment, the big picture view.
Exactly. Complex cases, weird presentations, integrating all the patient info that still requires the human expert, plus, regulatory hurdles, ethical questions. It's complicated.
Okay, so augmentation. What are some real-world examples? What's AI doing now?
Dr. Kotler gave some great examples. Triage is a big one.
Triage, meaning sorting which scans get read first.
Yep. AI algorithms can scan images incredibly quickly and flag the critical stuff. Think intracranial hemorrhages, PEs, things that need immediate attention.
So it bumps those urgent cases right to the top of the radiologist's work list.
Exactly. Yale New Haven, Cedars-Sinai, Christiana Care, they mention hospitals using this. And reporting real benefits, shorter lengths of stay, smoother flow through the ER.
Wow, okay. That's tangible impact.
Definitely. And it's not just emergencies, workflow improvements too, like unremarkable CXR batching.
Grouping the normal chest x-rays together.
Yeah, or similar things for screening mammograms. If the AI is confident there's nothing wrong, it lets the radiologists focus their time on the studies that actually need a close look. Saves time, saves money, potentially.
Makes sense. And beyond reading scans, Anything on the image capture side?
Oh, yeah. AI for image reconstruction, making MRI and PT scans way faster. That's huge for patient comfort and throughput.
Faster scans, less time in the tube. Patients would love that.
Absolutely. And cardiac MRI, which is notoriously complex, AI is helping there too. Planning scans, tuning parameters, monitoring quality, even analysis afterwards, reducing clicks, saving time.
So CAD systems, too. Computer-aided detection and diagnosis.
CAT-MIIT and CAT-X, yeah. Across different modalities, helping find things, helping characterize them.
Interesting. And then there's the brain health angle from Dr. Kademi's talk.
Right, Dr. April Kademi. Focusing on how AI can tackle the pain points in analyzing brain scans, especially over time.
Like tracking disease progression, things that are hard to measure manually.
Exactly. Manual measurements can be tedious, subjective. AI offers objective, quantitative biomarkers. Better quality, faster turnaround.
And that helps with, what, clinical trials?
For treatment decisions.
Both. Stratifying patients, figuring out who's most likely to benefit from a certain intervention or who fits the criteria for a trial. And prognostication, predicting outcomes for more personalized medicine.
She mentioned specific tools for FLAIR MRI.
Yeah, robust tools for conditions like dementia, stroke, gliomas, built using a massive data set like 1 million MRIs. They can find novel biomarkers.
1 million MRIs? Wow. And pathology, too. Digital pathology. Yep. Breast cancer AI tools for quantifying Ki-67, that's a marker for how fast cells are dividing. Studies show it improves accuracy, consistency between pathologists, and speed.
And platforms like PathCore Flow TM help integrate these tools into the lab workflow.
Right, making it practical.
Okay, so lots of potential, lots of tools being developed, but getting them into actual clinical use. That's another story, right? Dr. Fine's presentation hit on that.
Dr. Benjamin Fine, yeah. He made it really clear. Clinical AI is not plug and play. No algorithm is perfect.
He had a framework, right, for governing AI.
Yeah, a high-level view. Procurement, development, integration, lifecycle management, and it's iterative, a continuous cycle.
And you need clear goals for why you're deploying AI.
Absolutely. Should we even use this tool? How should we use it? What results should it show? And to whom? He boiled success down to clinical ROI plus business ROI plus trust. You need all three.
Trust is a big one. So how do you build that? What about evaluation before you go live?
Crucial. Pre-deployment evaluation. Check its performance on your data, look at subgroups, get your experts to audit its findings, analyze the workflow impact.
He had that slider concept too, which I thought was neat.
Yeah, adjusting how much evaluation effort you put in based on risk, how novel the AI is, your own experience, the vendor's track record. Makes sense, right? Not a one-size-fits-all approach.
Definitely. And he warned about pitfalls. The generalization gap.
Right. How well does it work on your patients versus the data it was trained on? Often there's a drop-off. And schema noise, inconsistencies in how data is labeled.
So external validation on your own data is non-negotiable.
Absolutely critical. He mentioned chest x-rays as a classic example where performance can vary wildly between hospitals.
What about practicalities, contracts, piloting?
All important. Contracting needs careful thought. Piloting may be a shadow deployment as a minimum, where it runs in the background without affecting decisions initially, gives you data.
And how you use the AI dictates how you set it up.
Right.
Right. The operating point.
Exactly. The use case drives the operating point. Are you using it to automatically clear normal studies? Then you need super high confidence that normal really means normal.
High negative predictive value.
Right. But if it's suggesting a diagnosis or treatment, maybe you need higher positive predictive value, more overall accuracy, fewer false alarms, even if you miss a few things. It's always a trade-off. Sensitivity versus specificity.
So you need to create the right patient cohorts for testing, measure the right things, accuracy metrics, workflow time, expert agreement.
Analyze the thresholds, yeah. And communicate the model's limitations. He mentioned model fact labels, kind of like nutrition labels, but for AI, transparency is key.
Okay, that's a really thorough look at the AI side. Let's switch gears. None of this works if systems can't talk to each other. Interoperability.
Huge topic at MIIT. Mahanad Hussein's presentation really laid it out.
Interoperability is just fundamental, isn't it, for AI, for everything digital in healthcare?
Couldn't agree more. And FHIR, Fast Healthcare Interoperability Resources, is really central to that now.
FHIR. It's like the modern language for health data exchange.
Pretty much. It's web-based, uses RESTful APIs, which developers love. It has that pull-push model for getting data. It's resource-based patient, observation, imaging study, logical chunks.
And human-readable formats like JSON or XML.
Yeah.
Easier to work with.
Definitely. And there are cool technologies built on FHIR, like FHIRcast.
FHIRcast. That was for syncing applications.
Yeah, keeping different apps on the same page. Like if you select a patient in your EMR, your image viewer automatically pulls up their scans. Seamless context switching.
Okay, nice. And smart on FHIR.
That's about securely launching third-party apps within the EMR, giving them controlled access to FHIR data. Much better than the old clunky integration methods.
Like an app store for healthcare almost.
Kind of, yeah. Standardized and secure. Then there's CDS hooks.
Clinical decision support hooks. Real-time feedback.
Right. You're ordering a scan, and maybe a CDS hook pops up suggesting a more appropriate study based on guidelines or points out a potential drug interaction integrated right into the workflow.
Very useful.
Yeah.
He also mentioned the International Patient Summary, IPS.
Yeah, using FHIR to create a standardized snapshot of key patient info, allergies, meds, problems for sharing across borders, increasingly important.
And how does FHIR connect to the imaging world, to DICOM?
Through the imaging study resource in FHIR, mainly, it links to the DICOM study. And DICOM itself is becoming more web-friendly with DICOM Web, which also uses REST. Just like FHIR, things are converging.
Good to hear. And IHE, integrating the healthcare enterprise.
They play a big role, defining profiles, running connectathons, those big testing events, like the one in Toronto where vendors prove their systems can actually interoperate using these standards.
They focused on one specific guide, the IDR.
Imaging Diagnostic Report Implementation Guide.
Yeah.
Yeah, basically making the FHIR Diagnostic Report resource work better for radiology reports. Standardizing how you encode findings, impressions, recommendations.
So other systems can actually understand and use the information in the report automatically.
That's the goal. Better integration, less manual data reentry.
He mentioned other IHE profiles briefly too. E by W, AIR, IMR.
Yeah, a whole alphabet soup. E by W for workflow, AIR for AI results, IMR for multimedia reports, IRA for real-time apps, POWR for worklist prioritization.
And AIR AI. AI results assessment for imaging.
Right. That one specifically looks at the workflow for AI results, how they're captured, sent, displayed, and how humans interact with them, review them, provide feedback. Closing the loop.
Okay, so standards are the plumbing, making everything else possible. What about the large-scale infrastructure, regional archives, DIRs?
Good transition. Don Dennison chaired a panel on DIR's diagnostic imaging repositories in Canada.
How are things looking there?
A bit varied, actually. Different levels of maturity. Some are just archives, some are shared PCS. There's definitely talk about consolidation, moving towards cloud hosting, still evolving.
Then we heard about Saudi Arabia, which sounded, well, way more ambitious. National scale.
Yeah, Monifeed's presentation was impressive. They're doing multi-specialty VNAs, vendor-neutral archives, not just radiology.
Multi-specialty.
Yeah.
Like what else?
Cardiology connecting different sites, CPACs, CVIS, ECG data, dentistry DICOM and non-DICOM images from thousands of clinics. Even pathology digital slides across dozens of labs, enabling AI analysis.
Wow, all feeding into a central VNA.
Seems like it. And they built a nationwide teleradiology platform, too, connecting 72 hospitals using Oracle Client remote subspecialty reads.
That's a massive undertaking.
It really is. He showed their Saudi enterprise imaging ecosystem model, integrating everything, radiology, non-radiology, national patient ID, the VNA. It's part of their whole Vision 2030 healthcare transformation.
Moving towards value-based, digital-first care. Quite the contrast to the more fragmented picture elsewhere sometimes.
Definitely a large-scale, top-down approach.
Okay, let's pivot again to something generating maybe the most buzz right now, LLMs and VLMs, large language and vision models.
Ah, yes.
Isn't that-
Dr. Jaron Chung's top 10 surprising things. That was fascinating.
What stood out? What was surprising?
Well, first off, their apparent ability to show empathy. Some studies comparing LLM answers to doctor answers on forums like AskDocs found the LLM sometimes rated higher on empathy.
Really, empathy from an AI. That's
Or-
unexpected.
Right. Potential for improving patient communication, maybe, but then there's the flip side.
It's just,
The needle in a haystack problem.
Hmm.
Just because you feed it tons of text doesn't mean it can reliably find specific facts, especially in the middle of a long document. Context windows still have limits.
primacy and recency effects.
Right.
Remembers the start and the end best.
Exactly. And get this, sometimes silly prompts work better.
Silly prompts.
Yeah, like telling the AI take a deep breath or think step by step. These weird anthropomorphic absurdities, as he called them, can actually improve reasoning. Bizarre.
Okay, what else?
Model cloning. How relatively easy it is becoming to distill knowledge from large models into smaller ones, or even just, well, steal their outputs to train new models. Lowers barriers, but raises huge IP issues.
And security worries, naturally. Prompt injection.
Big one. Tricking the model with malicious inputs. He mentioned model context protocols, MCPs, as a potential defense, defining how they should interact with external data.
Then there's voice mode.
Oh yeah, sophisticated voice interaction. Could totally disrupt call centers, change how patients interact for scheduling, simple questions.
And the whole issue of guidelines. National versus generic AI knowledge.
National guideline sovereignty, he called it. Using RAG retrieval augmented generation to ground responses in specific local documents helps, but ensuring adherence to all the local nuances is tough.
Interesting. He also talked about the cost of code dropping.
Yeah, the idea that coding might become essentially free. Huge implications for automation in healthcare IT, FHIR integrations, analytics could become much easier.
But also, zero-cost attacks.
If the tools for creating attacks become free and easy to use, yeah, that's a worry. Democratize cyber threats.
And finally, education.
Reshaping it. Interactive learning, personalized tutoring. AI could change how we train healthcare professionals too.
Lots to think about there. Powerful tools, but with complex implications. Which brings us neatly to cybersecurity.
Always a critical topic in healthcare. Praveen Balkaran gave a sobering overview.
Healthcare is just such a prime target, isn't it? The data's valuable, the impact of downtime is immense. Life and death, potentially.
Absolutely. He hammered that home.
Right.
The cost of breaches is huge, and attackers are getting more sophisticated, targeting third-party vendors, nation-states collaborating with ransomware gangs.
What are the biggest threats specific to healthcare right now?
All the usual suspects, amplified. Vulnerable legacy systems, data breaches, obviously, insecure medical devices, big worry there, ransomware, DDoS attacks. Phishing is relentless.
Fragmented security across different departments, tight budgets, risks from all those third-party connections.
Exactly. It's a complex threat landscape.
What are the key lessons learned? What absolutely has to be done?
The basics are crucial. MFA, multi-factor authentication, is non-negotiable. Incident response planning and testing. 24/7 monitoring. Vulnerability management. Solid backups and disaster recovery. Again, tested.
Training for staff is huge too, right? Against phishing.
Massive. Plus, privileged access management, PAM, red team exercises to simulate attacks, good endpoint detection and response, EDR.
And now AI adds a new layer of threats.
It does. AI-powered phishing that's harder to spot, data poisoning, corrupting the data AI learns from, deepfakes for impersonation, trying to reverse engineer models.
Plus risks from staff using external AI tools, lack of governance, data privacy issues with AI vendors, no standard security frameworks for AI yet.
And just general lack of user awareness about AI-specific risks.
So what's the strategy? How do you build resilience?
It's multi-layered. Regular risk assessments using frameworks like NIST CSF or ISO 27001, specific AI governance NIST AI RMF, ISO 42001, red teaming, penetration testing, vulnerability scans.
Strong identity management, cloud security audits if you're using cloud services.
That 24/7 monitoring, again, solid emergency response, BCPDR plans audited, ransomware simulations, incident response, tabletop exercises. Know your crown jewels, he said. Protect what matters most.
That sounds like a constant battle.
It really is. Vigilance is key.
Okay, from the high tech and high threat, let's shift to something really inspiring. Expanding access. Greg Toffner's talk on task shifting in the Arctic.
That was a fantastic story. Really highlights innovation driven by necessity.
Task shifting. That's basically training local people to do jobs they weren't originally qualified for, right? Because of workforce gaps.
Exactly, especially in places like Canada's high Arctic, where getting healthcare professionals is incredibly difficult and the health disparities are stark. Access to basic services is a huge challenge.
So they set up an X-ray training program in Nunavut.
Yeah, training community members, often local Inuit employees recommended by the health centers, to become basic radiological technicians, BRTs, in 25 remote communities.
How does the training work?
It's blended. Some parts delivered on-site in the communities, phases of learning, plus online support. Very practical.
And the images, who reads them? How does quality control work?
That's done remotely. Images go through the territory-wide PASS, integrated with the EHR, and radiologists in Ottawa provide the reads and quality control.
That's clever, using technology to bridge the distance.
Absolutely. And the government and health authorities are increasingly recognizing the BRT role.
So the benefits are?
Huge. Better access to basic diagnostics right there in the community, more sustainable healthcare, more efficient, less need for patients to travel huge distances for a simple X-ray, which is disruptive and expensive.
And meaningful jobs within the communities. That's fantastic.
A really positive example of adapting to challenging circumstances.
Definitely. Okay, one last quick mention, open source software. Bill Wallace touched on that.
Yeah, just highlighting its importance in fostering innovation and collaboration. Tools like OHA Viewer, the Orthanc Passies server, Total Segmentator for AI, open source, drives a lot of progress in this field.
Good point. Allows people to build on each other's work.
Exactly.
All right, so wrapping up this deep dive into MIIT 2025. Quite a landscape.
Definitely. Key themes emerge, right? AI is here, it's augmenting, not replacing, but deployment needs care. Interoperability standards like FHIR are the crucial glue holding it all together.
Regional and even national systems like VNAs are showing the potential for large-scale image sharing across specialties.
LLMs and VLMs are bursting onto the scene with surprising abilities, but also new complexities and risks. Cybersecurity is an ever-present battle requiring constant resilience building.
And innovation isn't just high-tech AI, it's also clever solutions like task shifting to tackle fundamental access issues.
MIIT 2025 really painted a picture of a field that's moving incredibly fast, dynamic, complex, exciting.
So hopefully this conversation has given you, our listeners, a good handle on these key developments, a shortcut to being informed.
And maybe leaves you with a final thought to chew on. With AI advancing so quickly and systems getting so interconnected, what ethical and practical challenges do you think are the most critical ones we need to solve in the next few years?
Yeah, how do we make sure everyone benefits equitably and securely from high-quality medical imaging as things evolve?
It's the big question hanging over all this progress. Definitely something to keep thinking about.
Absolutely. The momentum is undeniable. Thanks for joining us for this deep dive.
The Dream Machine.com, HL7IHE in the snap. We're building the future, never looking back.